Okay, hello. This is Doug from Stats, and as you know, Tuesday night we can't. Shawnee State University canceled classes because of weather. If I'm if I'm counting correctly, that means the first 5 weeks we've met twice. So next week, hopefully you'll remember me, and we'll probably have to go through introductions again. And you can tell from my screensaver where my heart really is. Wouldn't it be nice to have our statistics class right there? Alright, gang, anyway, this is the 5th video. Again, after we've missed so much class, this is the way that I've kind of chosen to stay in touch with you. So the purpose of this video is to get into predictions more and to talk about something really important in regression and correlation, something called residuals. So now that's the purpose. So I'm anticipating there's probably going to be 3 videos. I'm going to try to keep them short because it makes them easier to upload to YouTube. Speaking of, first of all, I want to apologize for this being posted so late in the week. I actually made the videos on Wednesday, and there's a new screen recording software, or a screen recording program, I should say, called Camtasia, and everybody's been talking about how great it is. And granted, it's great for the recording, but I have a glitch in my system and can't upload it to YouTube. So this is Friday morning, and I'm redoing the videos, and hopefully I'll get them up this afternoon. So, which will be irrelevant because when you watch this, they'll be posted. So, guys, anyway, let's review what we've got going on. The purpose of the first 4 videos has been to use a car's horsepower to predict its miles per gallon. So our horsepower is going to be our X, our miles per gallon is going to be our Y. So making life a little easier, what I would want to do is I would want to go to Stat, go to Edit, and I would want to enter the data in the calculator accordingly. I always want my X values to go in L1 and my Y's to go in L2. Now, if you're just entering data, let me show you something that's pretty cool and kind of important. If you've already got data in a list and you want to get rid of it, you want to delete it. If you just want to hit just delete one entry, then just highlight the entry and come over here and hit delete, and it'll go away. But if you want to delete all the entries but not eliminate the list, you go up and highlight the list and hit clear, enter. Now what that's going to do is going to get rid of all the entries in the list and keep your list for future use. Now in this situation I only had 2 numbers, and I could have deleted those easily number by number. But imagine having 50 numbers stored. It's going to take quite a bit of time to go through and delete them one by one, where that's much simpler. So the very first thing I'd want to do again is enter my data where my X's are in L1, my Y's are in L2. Next thing I want to do is run the analysis, and I'm going to do that with Stat. I'm going to go over to Test, and I'm going to scroll down, and actually it's going to be easier to scroll up to linear regression t-test. Hit enter. Make sure L1 and L2 correspond to X list and Y list. Make sure your frequency is 1. Guys, this line right here doesn't matter. In 1500, we don't perform regression at that level. Come on down to Y1. I've showed you, I think, in video number 3 how to put that there. And come to calculate. By the way, it is really important that you have Y1 in the regression equation, so make sure you get that taken care of. Alright, gang, hit enter. And we've got some pretty cool stuff on our output. First thing we need to do is scroll to the bottom, and we can see that our correlation coefficient R, the last entry, is negative 0.68. We can see that our R squared is 0.4596. We report that to a percentage, so we would report that to 46.0%. And if we go on up to the top, you can see that we have our A and our B. Our A is our intercept, and our B is our slope. So the A would be 32.89, and our slope would be negative 0.052. Now, if I go to my iPad, you can see that that I have this already written down. And again, let's talk about this R. Remember, I gave you in a previous video, I broke a segment up from -1 to +1. I'm not going to do this again because I've already done it. But I broke the segment up into a variety of pieces. I think there were 5. And negative 0.68 would fall in that part right there, which stands for a negative moderate relationship. So we have a negative moderate relationship between horsepower and miles per gallon. The R squared tells us that 46.0% of the variation or spread in miles per gallon can be explained by small changes in horsepower. But what I want to focus on in this video is our regression model as we use it to make predictions. Now, for example, let's say that we want to predict the miles per gallon when horsepower is equal to 250. Now we go back to our data set and we see cars around 250. Here's one 245 and it had an observed miles per gallon of 23.5. But really we don't get much information because even if we had a car in our data set that had horsepower 250, we expect variation across all cars with a horsepower of 250. So what we would want to do is one approach to solving this would be to go to the calculator. And let's get to the home screen. And we could just put 250 in our model. So we have 32.89 minus, all right. Well, my calculator has just gone insane. So 32.89 minus 0.052 times 250. And if we hit enter, we see that our predicted miles per gallon would be 1989. Now guys, that's a reasonable way to make a prediction, but there's a much better way that we can make a prediction using our calculator, and I want to show that to you, okay? So file this under a better way to make predictions. Guys, if we go up here to second function, now let me back up. Let's do this first. If you've done everything I've asked you to do, if you come up and hit graph, and I had just hit the second function graph, which is not what I want. Okay, let me go up and do this. Let's go up and make our scatter plot. And I've been doing some stuff in the background before I set up the video. Alright, so let's make sure our scatter plot is set for L1 and L2. And then let's go zoom 9 to get a picture of our data. Now, once we've completed the linear regression t-test, you can see that the scatter plot, which I showed you in video 1, which didn't have this line, it now has the line. And the reason it has the line is when we conducted our linear regression t-test, we put that y1 in for our regression equation. So from there on out, once we now look at our scatter plot, it's going to have this line, which again is used for prediction. So if I want to use this, the graphing calculator to make a prediction for 250, I would go second function, calc. I would go to value, so I just hit enter. And again, if you've done everything I've asked you to do, in the left-hand corner, in the bottom left-hand corner, you're going to have x equal. Well, this is where we're going to type the value of the, in this case, horsepower that we want to make the prediction of. Now, when I make my prediction here, I get 19.83. Now, how does that compare to what we got before? Well, before I got 19.89. Now, there's not a substantial difference there, but there is a difference. And the reason is when I made my calculations, my predictions on the home screen that we're looking at right now, I used 32.89 as my intercept and negative 0.052 as my slope. But if you go up here to Y1, you can see that the calculator, when we use it to make our prediction, it's using the intercept, I think, out to about 10 or 12 places. So the calculator gives us a lot better estimate or a prediction, in this case, of a horsepower, well, the miles per gallon for a horsepower of 250. All right, there's another feature that's equally important. Let's say, for example, that we want to not predict 250, but we want to predict the miles per gallon when we have a horsepower of 400. Well, if we use this approach, and I can do something kind of clever here and go second function entry, which allows me to just type over what I want. We're going to get predicted miles per gallon of 12.09. And you might think, that seems reasonable. You know, a car with that much horsepower would get a small, probably a small predicted miles per gallon. But let's do it the right way, the best way. So we go up here, second function calc. We go to value, and we type in 400. We get the bad screen. That, guys, typically when you get this screen, it'll drive you insane. It means you've done something incorrect. This means you've done something correct. The calculator is keeping us honest because our model wasn't built to make predictions at the level of 400. Guys, a simple investigation of our data will show that the lowest the lowest horsepower we have is 130. The highest horsepower we have is 322. Guys, our model isn't any good below 130 and above 322 because we don't have data out there. If we make predictions, it's called extrapolation. And guys, extrapolation is not cool. And I always tell this story. If you went into a kindergarten and collected some data on 4, 5, 6-year-olds, and you create a model, would you feel comfortable going into a nursing home of people 70, 80, potentially 90 years old and using your kindergarten model to make predictions in a nursing home? Well, you wouldn't, because the model wasn't built for people of that age group. Well, guys, our model wasn't built to make predictions at the level of 400 because the maximum data that we have is 322. Now, at the end of the day, what is this telling us? At the end of the day, what we're saying is when we have data in a scatter plot like we have in this problem, where we're looking at horsepower as our X and miles per gallon as our Y. Well, we've collected some data, but there's a minimum value and a maximum value of our data set. Well, we built our model between those two values. Now, what happens out here? I have no idea. Our data might have gotten real wacky out here and done something crazy. What happens down here below our minimum? Again, I have no idea. I don't have data down there. So at the end of the day, we're using data to make informed decisions. And we can't make informed decisions if we don't have data in that particular part of our on our in this case of our horsepower. All right, guys, let's go on with the next topic, and the next topic is extremely important. And the next topic is what we call residuals. And guys, residuals are nothing more than the observed Y minus the predicted Y. If you've done stuff as I've asked you to do it, your observed Y will be stored in L2. So guys, if we go back to our data set, the observed Y for the Audi 200 would be 23.1. The observed Y for the BMW would be 16.7, and so on and so forth. The predicted Y we're going to make using our model. And in our case, I forget exactly what our model was, but in our case it was, I know our slope was negative, I think 0.084, but I'm not sure. So anyway, we're going to use our predicted Y, find our predicted Y by using our model. So guys, let's do this. Let's calculate the residual. For the Audi. So we'll go back and get some information on the Audi. The Audi has an X value of 162 and it has a Y value of 23.1. Okay? So let's go back to this. So therefore, to calculate the residual, we're going to take our observed Y minus our predicted Y. Well guys, it's pretty cool when you get down to something that just requires you to do a simple subtraction. It's all about knowing what to put in the two parts. Well guys, as I said before, our observed Y is what we get, it's what we collected when we took our measurements. And the observed Y for the Audi is 23.1. Again, the observed Y is always going to be the Y value that we have in our data set. The predicted Y is going to be the value for Y when we put this car's horsepower, 162, into our model. So we found a slicker way to do that, right? We found that keeps us honest if we'll go second function calc, value, put in 162, because this is the horsepower for the Audi, what we're trying to calculate the residual for. And we see that down here that 24.43 is the predicted miles per gallon. So 24.43 is the predicted. So let's grab our calculator real quick. And we see that the Audi has a residual, if I put everything in correctly, of negative 1.33. Now, what does this tell us? Well, by simple investigation of the observed and the predicted, we can see that the predicted value is higher than the observed. So based on the horsepower, again, based solely on the horsepower, the Audi isn't getting as good of a miles per gallon as our model would have predicted. So if you're, hung up on miles per gallon, which, we all should be efficient, I guess, and if you drive a lot, 1.33 miles per gallon, if you don't drive much, it doesn't seem like much, but if you drive 35,000 miles a year, 1.33 miles per gallon difference could make a substantial difference. Now let's do another one. Let's just go in and choose some other random car. Let's go down here and look at this Rolls Royce. I don't think I've ever seen a Rolls Royce. But anyway, the Rolls Royce has a horsepower of 236. And I'm writing this down. And a miles per gallon of 13.2. All right, gang, back to the other screen. So the Rolls-Royce has, again, horsepower 236, miles per gallon 132. So the Rolls-Royce has a residual. And this should be pretty clear. First thing we do is we use the observed Y minus the predicted Y. So we need to go back to our calculator, calculate the miles per gallon for 236. So repeat the steps. Second, calc, value, 236, and hit enter. So the predicted miles per gallon for the Rolls-Royce is 20.56. So 20.56. Now, I don't know much about Rolls-Royces, but I know they're expensive. I also know I'll never own one, especially after seeing this. If we calculate the residual for the Rolls-Royce, we get a negative 7.36. So I really don't know what's going on with the Rolls-Royce people, but based on horsepower alone, their car should probably be getting better gas mileage than what it actually was observed to get. Now, guys, at the end of the day, what happens? Residuals are tied into the difference between what we observe and what we predict. So let's just take some arbitrary scatter plot. Again, this is not the one we're dealing with. This is just one that I'm just doing for an illustration. If we fit a model down the central focus of the data, let's come in and focus on this point right here. This point right here is our observed Y. So if we would take this over to our Y-axis, that would give us our observed Y. This, of course, is going to give us our X value. If we put this X value in our model, it's going to have a Y value right there. So guys, this is the predicted Y. This is the observed Y. Now, you can see that our observed Y is less than our predicted Y, so this point right here is going to have a negative residual. In fact, all points below the line are going to have a negative residual because their observed Y is less than their predicted Y. On the other hand, let's take the same argument for this point right here. I'm going to make it real big so it points, so it stands out. This is the observed Y. The predicted Y would be right here. Clearly, our observed Y is bigger than our predicted Y. So this point right here would have a positive residual. So guys, in a nutshell, points above the line have positive residuals, points below the line have negative residuals. And obviously a point on the line would have a zero residual because it's observed and predicted values would be the same. All right. Why do we do this? Why do we care? Okay. Now, first of all, we only have, what, 10 cars here? So it wouldn't be hard to go through and calculate the residual for each car, but there's an easier way. So what I'm going to show you now is I'm going to show you how on your calculator to kind of cleverly calculate and store all of your residuals. Now, guys, first and foremost, before you even start this, you must run the linear regression t-test. So before I ever start examining residuals more wholly on the calculator, if you will, I have to go to stat, I have to go over to test, I have to come up to linear regression t-test, and I have to conduct the analysis. All right, hit enter. Now, the moment I hit enter, the calculator did some cool stuff. It calculated R, it calculated R squared, it calculated A, the intercept, it calculated B, the slope. It also just calculated the residuals. What we have to do is we have to know where to go get those. So guys, let's just clear out the home screen. And I want you to go second function stat. And what I'm hitting by doing this, I'm hitting my list button. And if you've done everything I've asked you to do, somewhere in that list, and you may have to scroll down or maybe closer to the top than mine, but somewhere on that list you'll see RESID. Gee, I wonder what that stands for. Hit enter, and what that does, it kind of copy paste that back into our home screen. Guys, we've got our residuals there. Now I want to store them someplace where I can see them. So I'm going to go hit the store button. Now on your calculator key, it says STO. But when you hit that on your screen, it'll just have an arrow to the right. Well, guys, we put our X's in L1, our Y's in L2. Makes sense to me. We would put our residuals in L3. So if I hit enter, again, if I've done everything correctly, it's going to show me the first residual. I could scroll over and see the residuals, but there's a much better way. If I go to stat and go to edit, you can see that the list of L3, which was blank before, now has the residuals. So the residual for the Audi whatever it is was negative 1.325. And if we scroll on down, we can see that the residual for the, let's see, what was the residual? Oh, there it is, negative 7.36, my bad. For the Rolls-Royce is negative 7.36. Now, this allows us to do some cool stuff with the residuals. For example, it would allow us to look at the mean and the standard deviation of the residuals. So we could go to calc, one variable stats. Residuals are in L3, so it makes sense to do one variable stats L3. Guys, the mean of the residuals is always 0. Your calculator is doing its best. It's giving you scientific notation form, telling us we need to move this decimal place 12 places to the left. That's 0. And our standard deviation is 3.70. We could also look at, if we wanted to, we could look at a box plot of our residuals. Well, box plots are easy to do. Just choose the right one. We don't want to do a box plot of L1. We want to do a box plot of the residuals. We want our residuals to occur one time, so we leave our frequency as 1. And just like we always do with this screen, we go zoom 9. And we can see that we have no outliers in our residuals. But guys, and I think I'm going to, I'll tell you what, I'm kind of running over. I'm going to stop the video here and complete the residual analysis in the next video. So, see you later.